Today we are going to get started with linear equations. We are going to go over day 1 and day 2. So first, we need to know how to identify a slope and y-intercept from a given equation. So there are two types of equations, a slope y-intercept form. So slope y-intercept form is y is equal to mx plus b. And the slope is m, and b is the y-intercept. But sometimes you may see a standard form. It looks like ax plus by plus c equals 0. This is a standard form, and standard form really doesn't tell us anything. So what you need to do, you always need to put it in a slope y-intercept form to identify slope and y-intercept. So there's two types. And remember, number 1 is the most useful one. So let's take a look at equation 1. So we have y is equal to negative 7 over 5x minus 3. So as you can see, we have negative 7 over 5 in front of x. So that is going to be my slope, negative 7 over 5. And a number or a constant that is after the x without a variable, in this case negative 3, is my y-intercept. Okay, so let's try another example. If you look at example 4, my slope is 1 over 5, and then my y-intercept is 5. Now, if you take a look at number 5, this is not a slope y-intercept form. It's a standard form. X and y are all the numbers are mixed together. So what I want to do is I want to isolate for y. So I'm going to move negative 7x to the other side. So on the left side, I have 2y. And on the right side, negative 7x now becomes positive 7x. And then 8 was originally there. And now, what's in front of y? There's 2. So we're going to divide everything by 2. So nothing is in front of y. Therefore, y is equal to 7 over 2x plus 4. So in this case, the slope is now 7 over 2. And the y-intercept is 4. So please keep in mind that we always need to put it in a slope y-intercept form. You want y to be alone. So let's try another example, number 9. So it looks like we have the standard form. So I'm going to move negative 5x to the other side. So on the left side, I have 3y. And on the right side, negative 5x, because it moved to the another side, it's going to turn it into positive 5x. And negative 9 is originally there. Now, what's in front of y? There's 3. So we're going to divide everything by 3. So that 3 and 3 cancels out. So you have y is equal to 5 over 3x minus 3. So it looks like from my slope y-intercept form, slope is 5 over 3, and my y-intercept is negative 3. Now, what about if I were to give you the slope and y-intercept and you have to write an equation? For example A, so slope is 3, so we can say that slope is 3, and my y-intercept is 7. So we're going to plug it into y is equal to mx plus b. So y is equal to 3x positive 7. And that's my equation. Let's try another one. Letter E. Slope is 0, and my y-intercept is 4. So again, y is equal to mx plus b. y is equal to m, I'm going to write 0x plus 4. But as you can see, 0 times any number is just 0. So they cancel out. So y is equal to 4. Okay. Now, so let's try a different types of question. So I want you to be able to graph a linear function from an equation. So when you are graphing, you always want to start with, number 1, label your y-intercept. And then after you label your y-intercept, you are going to translate the slope. The slope, the formula is rise over run. Okay, so let's start with this example. Example 1. So it looks like my y-intercept is -2 and my slope is 6 over 5. So if it's 6 over 5, remember it's rise over run. So therefore, rise is 6, positive 6. So I'm going up 6, and the run is left or right. So rise is up or down, run is left or right. So if it's positive 5, we're going to go right 5. Or another way to do this, do the total opposite. Opposite of up is down 6, and opposite of right is left 5. Because -6 over -5 also gives you 6 over 5, because double negative gives you positive. So let's start with labeling -2 on my y-intercept. And then this time, I'm going to go up 6 and right 5. So 1, 2, 3, 4, 5, 6. And then let's go 5. 1, 2, 3, 4, 5. That's my next point. Another, we could go down 6. So 1, 2, 3, 4, 5, 6. Okay. 6. And then left 5. So 1, 2, 3, 4, 5. Oops. So my next point is over here. So I move down 6, and then I move left 5. So then, using your ruler, you could draw a straight line with arrows at both ends. So I would like to see approximately 3 points for every graph. Okay. Now let's try another example. Example 4. So this time it's a standard form. So I want y to be alone. So I'm going to move 2x to the other side. So y is equal to positive 2x now becomes negative 2x plus 5. So let's write down the given. So y-intercept is 5. My slope is -2. But slope always is rise over run. So I'm going to just write it in over 1, invisible 1. So what does this really mean? Well, if it's -2, that means we're going down 2 or right, oops. So we're going right 1, okay. Or another way you could do the opposite. So I could put 2 over -1. So that means up 2, and we're going left 1. One or the other is okay. So let's label the y-intercept, which is at 5. This is my starting point. And then I'm going to go down 2 and right 1. So down 2, 1, 2, and right 1. Okay. Again, I could go down 2, 1, 2, and right 1. And there you have it. 3 points that has a negative slope. As you can see, the negative slope means it's going down. As I read the graph left to right, the graph is going down. Okay, So I will need to see 3 points. Next, let's try number 5. So y is alone, but what's in front of y? It's 2. So I want to divide both sides by 2 so it cancels out. So I now have y is equal to -1. So there's no x here. So what does that mean? It must be, the slope must be 0, right? There's no x. And my y-intercept is -1. So if there's no slope, it actually means it's a horizontal line. So label your y-intercept -1, and the line y is equal to -1 will be like this, because there's no slope. Slope is 0. On the other hand, if you have x is equal to, let's say, a number, that means the slope does not exist. It's undefined. So therefore, your graph is going to be a vertical line. Okay, so try to remember the exceptional case where when the slope is 0, it's always going to be a horizontal line with the equation y is equal to a number. If you have a slope that does not exist, it's going to be a vertical line, and the equation is going to be x is equal to a number. Okay, so this is a 2 special case that you need to remember. Now let's go over day 2. So we now going to take a look at how to graph lines using the intercepts method. So intercepts method means that x-intercept is when we let x equal 0, and y-intercept we let x equal 0. So x-intercept is always on the x-axis, and y-intercept is always on the y-axis. So what we can do is we are given an equation here, and let's plug in the numbers. So to find x-intercept, I'm going to let y equal 0, and you solve for x. So it looks like x is equal to 1. Now to find y-intercept, I'm going to let x equal 0 minus 1 equals y, and 0 minus 1 is -1 equals y. So let's label my x-intercept is x is equal to 1, so it's on the x-axis at 1, and my y-intercept is on the y-axis when it's at -1. And then you can just connect the 2 points. And that's how you draw the graph using intercepts. Okay, let's try example 3. So we're given this equation. So to find x-intercept, we're going to say let y equal 0. So I'm going to plug in 2 times 0 equals 6. So 7x, 2 times 0 is just 0. So 0 equals 6. So then 7x equals 6. And we're going to divide both sides by 7, because we want to isolate for x. So x is equal to 6 over 7. So that's my x-intercept. For y-intercept, we're going to say let x equal 0. So I'm going to plug in 0 into x. So 7 times 0 is just 0. So I just omit it. So 2y equals 6. And we're going to divide both sides by whatever it's in front of y, so which is 2. So therefore, y is equal to 3. So I can label my y-intercept on the y-axis at 3. And my x-intercept on the x-axis at 6 over 7. So it's like barely 1 over here. This is 6 over 7. So then we can connect the 2 points, and the graph will look like this. Okay. Now, what about if I were to give you a table of values? Well, the table of values is actually one of the easiest way. All you need to do is just plot the points. So when it's at 0, when x is 0, y is -3. So 1, 2, 3, so -3 here. When x is 1, my y is -1 over here. And then when x is 2, my y is 1. So when x is 2, my y is 1. And when x is 3, my y is 3. So go at 3 over here, and I'm going to go up by 3 here. So it will be here. And when it's at 4, it's going to be 5. And therefore, once you have it, you can just connect the points. Okay, so this table of values is actually very easy. And lastly, what about if I were to give you an equation and you have to make a table of values? So when you're making a table of values for x, always use -2, -1, 0, 1, 2, the central values. So let's try the first example. Y is equal to 2x plus 5. So -2, -1, 0, 1, 2. So I'm going to plug in -2 into x. So 2 times -2 plus 5, which is -4 plus 5. When you add it, it becomes 1. So you're going to do same thing. So -2 plus 5, so it gives me 3. And then plug in 0 into x. It's going to be 0 plus 5, which is 5. 2 times 1 plus 5. So 2 plus 5 is 7. And 2 times 2 plus 5. 4 plus 5, so it's going to be 9. So there you have it. So the first point, you can see it's going to be -2 and 1. So when my x is at -2 over here, my y value is going to be 1. And then you're going to follow, so at -1, my x is 3. When it's at 0, it's 5. So this is 5. When it's at 1, it's 7. And then when it's at 9, when it's at 2, it's 9. And you're just going to connect all the points that you drew. So please use a ruler and don't forget the arrows at both ends.